Today we are going to study question number 9 from exercise 8.1 of CBSE class 10 NCERT mathematics textbooks, that is related to the trigonometric portions. Now let us have a look at the question. In triangle ABC, right angle at B, if tan A is equal to 1 by root 3, then find the values of sin A into cos A plus cos A into sin C. Now let us have a look at the question. We are given a triangle, and the peculiarity about this triangle is that it is a right angle at B, and we are given with the value of one trigonometric value, that is tan A is equal to 1 by root 3. That means we can get the values of two sides of this triangle from the value of tan A. We have to find the third side of triangle and the value of it. Then we can easily solve this question. That is, we can find the values of sin A and cos C, cos A and sin C from the triangle we have done. So now let us have a look at the answer. In this question we are given with the clue that the value of tan A is equal to 1 by root 3. You have already learned about the formula for finding the values of tan. That is, opposite side by adjacent side is the value of tan A. That is, opposite side of angle A divided by the adjacent side of angle A is 1 by root 3, we can assume. So we are also given that in the question that a triangle ABC is there with the right angle at B. So let us draw the triangle then. We have drawn a triangle ABC where the right angle is at angle B, and the value of tan A is equal to opposite side by adjacent side, which is 1 by root 3. So we can say that in triangle ABC, BC is the opposite side of angle A and AB is the adjacent side of angle A. So therefore we can find the values of BC and AB from the question itself. That is, BC is equal to 1 and AB is equal to root 3. Now we have to find the value of AC. In case of a right triangle, if we are given with the values of two sides, then we can find the value of third side by using a theorem called Pythagoras theorem. We have already learned about in the smaller classes. Then we also know the theorem for what Pythagoras says. It states that the hypotenuse square is equal to the sum of the squares of other two sides. In this triangle ABC, hypotenuse is AC and the other two sides are AB and BC. Therefore, we can convert it into the formula as AC square is equal to sum of the squares of other two sides, that is AB square plus BC square, which we have written here. AC square is equal to AB square plus BC square. We also know the value of side AB, that is root 3. AB square means root 3 whole square plus BC square. The value of BC is 1 and BC square is 1 square. That is 1 itself, and the square of root 3 is root 3 into root 3, which is 3, plus square of 1 is 1. Therefore we get that 3 plus 1 is the value of AC square. That is, AC square is equal to 4. But we need to find the value of AC, not the AC square. In order to find the value of AC, we have to apply the square root of 4. That is, the square root of 4 is 2. Therefore we got all the values of three sides. We have already find AB as root 3, BC as 1, and now we have find out the value of AC as 2. Since we have got the values of all three sides of the right triangle ABC, we can now let us have a look at the question itself. That is, we have to find the value of sin A into cos C plus cos A into sin C. For that, we have to find the individual values of sin A, cos C, cos A and sin C. Now let us have a look at each of these. For finding the value of sin A, we know the formula for finding the values of sin A. That is opposite side by hypotenuse. And it is given as angle A, sin value of angle A. So we have to look at the opposite side of angle A. The opposite side of angle A is BC. And the hypotenuse will be same for every equation. So we need not have to be careful while doing that. We have to be very careful at looking which angle is considered for the values, trigonometric values. Here it is sine of angle A, that is the opposite side of angle A divided by hypotenuse. Opposite side of angle A is BC divided by the hypotenuse AC. The value of BC is 1 and the value of hypotenuse AC is 2. That is 1 by 2 is the value of sine A. Next we have to find the value of cos C. For finding the value of cos, the formula is adjacent side by hypotenuse. Here the trigonometric values of cos is given for the angle C. So we have to look at the adjacent side of angle C. In the triangle ABC, the adjacent side of C is BC. And the hypotenuse is AC for every trigonometric equation in the case of right triangle. So it is BC by AC. The value of BC is 1 and the value of AC is 2. Therefore, the cos C value is 1 by 2. We have solved it here. Next, we have to find the value of, we have already found the value of sin A and cos A. Next, we have to find the value of cos A. The formula for cos A is adjacent side by hypotenuse. It is given as cos of angle A. So adjacent side of angle A divided by hypotenuse. In the triangle, the adjacent side of angle A is AB divided by hypotenuse AC. That is root 3 by 2 is the value of cos A. Now let us have a look. The value of cos A, adjacent side of angle A divided by hypotenuse. That is the adjacent side is AB and the hypotenuse is AC. That is root 3 by 1. Next we have to look at the final value, that is sin C. That is the sin value of angle C. We know the value of sin is opposite side by hypotenuse of angle C. In the case of right triangle ABC, the opposite side of angle C is AB whole divided by the hypotenuse AC. The opposite side of, that is the AB value of AB is root 3 and the hypotenuse value is 2. Therefore, the value of sin C is root 3 by 2. We have thus found the values of 4 trigonometric values and now we can easily solve the equation. From the right triangle ABC, we have found the values of sin A as 1 by 2, cos C as 1 by 2, cos A as root 3 by 2 and sin C as root 3 by 2. These are the 4 trigonometric values we require to solve this equation. That is sin A into cos C plus cos A into sin C. Now let us substitute these values in this equation. In place of sin A, we can write 1 by 2. In place of cos C, we can write 1 by 2 plus in place of cos A, we can write root 3 by 2 and in place of sin C, we can write root 3 by 2 and thus it becomes 1 by 2 into 1 by 2 plus root 3 into root 3 by 2 into root 3 by 2 and we can solve as 1 by 2 into 1 by 2 is 1 into 1 is 1 and 2 into 2 is 4, that is 1 by 4 plus root 3 into root 3 is 3 and 2 into 2 is 4, that is 3 by 4. Thus we get it as 1 by 4 plus 3 by 4. On solving this, it becomes as 1 plus 3, 4. 4 divided by 4, that is 1. And we got the final answer of sin A into cos C plus cos A into sin C as 1. Where the values of triangle is AB is root 3, BC is 1 and AC is 2 in case of a right triangle ABC. There is also a second part of this question where we have to find the value of cos A into cos C minus sin A into sin C. Now let us find the values of each of these trigonometric values. That is cos A. The cos value of angle A is adjacent side by hypotenuse. The adjacent side we need to consider is about angle A. So the adjacent side for angle A is AB divided by the hypotenuse AC. That means root 3 by 2. AB is root 3 and AC is 2. And now we have to find the value of cos C. The value of cos of angle C is adjacent side of angle C divided by hypotenuse. The adjacent side of angle C in case of right triangle ABC is BC divided by the hypotenuse AC. That is the value of BC is 1 and the value of AC is 2. That is 1 by 2. We got the value of cos C as 1 by 2. And the third trigonometric value we need to find is about the sin A. The formula for finding sin value is opposite side by hypotenuse. The angle we need to consider is angle A. The opposite side of angle A is BC and the AC is the hypotenuse as always, which means value of BC is 1 and the value of hypotenuse AC is 2, which means we get the value of sin A as 1 by 2. Here we got the value of sin A as BC by AC as 1 by 2. And the final trigonometric value we need to find is about the sin C. The value for finding the sin value of angle C is Opposite side of angle C. The opposite side of angle C is AB, that is root 3 divided by the hypotenuse AC2. Thus the value of angle C, sin C is root 3 by 2, which we got as under. Sin C is root 3 by 2. And thus we got all the 4 trigonometric ratios we need to get for solving this equation. And now let us see how we solve this. We need to find is for cos A into cos C minus sin A into sin C in case of right triangle ABC, and we got all the values. For cos A we got it as root 3 by 2, for cos C we got it as 1 by 2, minus for sin A we got it as 1 by 2, and for sin C we got it as root 3 by 2. Now let us substitute all these 4 equations in place of this. For cos A we have written it as root 3 by 2. For cos C we have written as 1 by 2 minus sin A into sin C. For sin A we have written as 1 by 2 into, for sin C we have written as root 3 by 2. Let us solve. Root 3 into 1 is root 3 itself. Any number into 1 is that number itself, and 2 into 2 is 4 as we know. So it becomes root 3 by 4 minus 1 into root 3 is root 3 itself, divided by 2 into 2 is 4. So we got it as root 3 by 4 minus root 3 by 4 when solving this equation, when we substituted the values of these trigonometric ratios. So we get root 3 by 4 minus root 3 by 4 is 0. And the answer for cos A into cos C minus sin A into sin C for right triangle ABC, where the value of AB is root 3, value of BC is 1, and the value of AC is 2 is 0.